This is one of those things when you see it, it looks more complex than what it really is. And I'm one of those type of people that when I see a math equation in physics or anything, I want to know where it came from. I don't just take it for granted that it works. I actually want to know how it was determined to be that way. Okay. So I look at this and I think, well, you know what? One day I was sitting, well, the same day, but after I thought about it for a while, I was just sitting and I thought, you know, according to the properties of logarithms, if I just start with a basic property of logarithms, does log a base b equal to x? Well, really, logarithms are just exponentials written in a different form, okay? Because that's just saying that b to the x equals a, right? Okay, what happens if I raise both sides of these to the power of c? Okay, I get b to the, I'm going to write as cx. Okay, because I'm raising a power to a power, so you multiply exponents. And whatever you do to one side of an equation, you have to do the exact same thing to the other. So I get a to the c, right? So now I'm going to take the logarithm base b of both sides. Log base b of b to the cx equals log of a to c, a to the c power. Okay? C could be any integer. All right. Now, well, it could be any number, rather. But now, thinking about this, the log of b to the cx base b is just going to be cx. How do I know that? Well, by definition, the log base b of b to the cx would be b raised to the cx. B raised to the cx, right? So if it's b raised to the cx, just going to have cx here. B raised to the cx equals b raised to the cx, right? So on this side, I just have cx. On this side, I have log a to the c, right? But isn't that interesting? Because originally I let x equal to log a base b. So I'm going to put that in for my x, and I have c log a base b equals log a to the c. That's what I wanted to prove. So I went back and I looked at it and I said, oh, wow, that's easy. But you really have to think about the properties of logarithms to figure it out. I had to go back to the properties of logarithms, the original property of logarithms. Usually, like, what you'll do is you'll take the function itself before anything's raised to a power, and you set it equal to a variable, and you start your proof from there. Then you start, like here, I let log a base b equal to x. So that's the same thing as saying b to the x equals a. And then I raised both sides to a power, and I took the logarithm base b of both sides, and ended up with cx equals log a to the power of c, log base b of a to the power of c. Okay. And then I looked at it and I said, you know what? This x is, I can replace this x by log a base b. Okay. So I had c log a base b equals log a to the c base b. And that's what I wanted to prove. So that's pretty cool.